Let's have a look at the good old binomial products. The word binomial in itself tells you what we're about to do. Right? Bi, that prefix means two. Nomial, I don't know if this is technically correct. It's probably a different, like nomial probably comes from Greek or Latin or something, and it probably has a different word, but basically it means terms. So binomials is something with two terms. That's right, polynomial, many terms. And so what we have is a binomial product. Something with two terms multiplied with something with two terms. Now, again, lots of different ways of doing this. Probably the most common one is what we call the FOIL method. You ever been taught that? First, outside, inside, last. Personally, I was taught the FACE method. You seen the FACE method? Oh, watch and learn. Okay, it still uses the same basic idea as FOIL. So first, but I actually draw the line in. And x times x, well, that's x squared. Outside, x times 1. Inside, 6 times x. And last, 6 times 1. And if I've done it correctly, I end up with a face. You see, the inside parentheses become the nose, the outside parentheses the ear, and of course they're happy because we've got the question right. There's the chin and some eyebrows. The face method. You see? Well, that's how I was taught. 6x and x, of course, can be added together. There's 7x. Then, now mathematics is the way I like to describe maths. It's all about studying patterns when you think about it. I mean, that's what we're doing. We look for patterns. And when it comes to things like algebra and that, we try and come up with formulas, but that's all a formula is. We discover the pattern, and then we come up with a way of, I don't have to do this every time now. I can just go straight to this new formula because I know, because of the pattern, the same thing will happen every single time. Because once you've got it, and that's the beautiful thing about maths, and proof in mathematics is different to proof elsewhere. Because in mathematics, once we prove it to be true, it is always true. Unlike some of the things that happen in science when really they're just theories, but they can't necessarily prove that they will always happen. They just think that they do. In maths, we can prove. And once we've proven it, it always happens. Because a plus b all squared is always a squared plus 2ab plus b squared. It will never be anything else. Every single time, that pattern will emerge. And with the negative 1, it's just the middle sign becomes minus 2ab. And the other classic one is the difference of two squares. So we end up with a squared minus b squared. And that can just save us a little bit of time when we see that in the algebra. We go, aha, we notice it. Bang, we know this pattern. This is the answer. So I see x plus 2 squared. Now, I don't actually write this line down. This is what I'm thinking in my head, because that's the whole point of the formula, I guess. Is that, yeah, it's that pattern, a squared, 2ab, b squared, but in this case, the a is x and the b is 2. Again, that's the thought process. Hopefully a lot quicker than I just did it then. We just wrote, well, yeah, of course, that's x squared plus 4x plus 4. 3x minus 4 all squared. So we see it. We know it's the first one squared minus twice the product. The last one squared. Bang, there's our answer. Difference of two squares. So again, it's the first one squared minus the second one squared. Just saves time. Here I've got a binomial times a trinomial. No neat formulas that I can think of. We just have to make sure that everything is multiplied by everything. So if I've got 2 terms in the first one, 3 terms in the second one, I should end up with 6 terms. They're the sorts of things you're looking for to make sure that you got all the terms. I'm expecting there to be 6 things. Again, there's nothing wrong with drawing the lines to make sure you've got them all. So, okay, a times 2 is a squared. A times minus 3a is minus 3a squared. 2 times a squared. Yep, got that one. Beautiful. I got my 6 terms. What adds together? Tidy it up. There's the answer. There's the answer. And when you're doing questions like this, yes, I know you can just write the answer down, but when you're writing it in your book, you don't just write down 4p squared minus 25. The question in algebra is key, because what you're really doing is you're producing something which you could show someone else, and explain to them. Now, if I pick up your book and all I see is 4p squared minus 25, that doesn't tell me anything. That doesn't tell me what you just worked out. I don't know what you started with to get that. The question might have been, what's 5p squared minus p squared plus 16 minus a big number, and I'm thinking I really wish I didn't pick 16 right now. But whatever that number is, that might have been the question. I don't know. So it's like, hey, this is what I'm starting with. This is what I end up with. This equals this. It's how we communicate our mathematics. Don't be lazy. 1b, we'll add some more questions there.